We're starting off with the notes for Algebra 1, 8.5. And today, guys, we're going to be introduced to factoring. So factoring, guys, is the opposite way of multiplying. So in other words, we are dividing. Okay? Opposite of multiplying is dividing. But we don't divide, we call it factoring because we're breaking it apart. So factoring, guys, is breaking a polynomial into its smallest pieces. So what would it take, or what would it look like when I took all of it apart into its multiplicative parts? So that if I multiplied things back together by foiling or distributing, I get the answer that I start with, or before I factor. And to do that, we talk about the GCF. What is a GCF? Greatest common factor. Greatest common factor. This is the one we're dealing with today. So today we're talking about the greatest common factor of everything. Which means, what does every term in that group have in common? AKA, what would everybody be able to give? Scenario. The scenario is everybody is going to make a donation to the Conchac Fund.
Conchac Fund.
This Conchac Fund needs to get me some food, so I get hungry once in a while. So, here's the thing. To make it fair, guys, we're going to give, everybody's going to give what everybody can. Or what everybody. So, basically, the highest amount possible that everybody can donate. Okay, listen up. So, Caden is the first one up, and Caden opens up his wallet and pulls out a crisp $100 bill. At this point, guys, I'm pretty excited. Okay, listen up. Listen how this works. Because if Caden was the only one in the group, I would get $100, yes? Because there's only one person. But Will shows up, he's in the group, and Will pulls out his wallet and goes, I've only got 80. Here's the thing, guys. I'm not really too disappointed because I'm still going to get what from everybody? I'm going to get 80 from everyone. Because 80 is the most that each of them can give. Then we roll on to Nick. And Nick says, boom, I have $125 in my pocket. How much am I getting from everybody?
80.
Still getting 80. Even though he can give more, everybody's still giving the 80. Yes?
Yep.
And then Marky Fresh shows up. He's in the group. And he pulls out a crisp $1 bill. Now, everybody has to give me $1. That's the greatest common amount that everybody has. You guys get the point of this whole exercise? Okay, good. That's what it means. So we're going to use that now to solve A and B. We're going to use the distributive property in reverse. Because, guys, I think all of us would know how to multiply that in. I would multiply C to the A and C to the B, right? Which would lead us to CA plus CB. But guess what? Both of those groups have a... Both of these groups have a C. Couldn't I divide both of them by C? Which basically says I'm going to give it up or give you a C. Boom. Which would lead us with A plus B. They go back and forth. One's factored form, one's expanded form. So, here's a really cool thing, guys. You can always know, or have the ability to know, if you did something right by multiplying your pieces back together, most of the time distributing or foiling, and see if you get the original problem. So look at the first problem. 15W minus 3V. What's the biggest thing that both groups have that they can donate?
3.
Anything else? Oh, they only can give a 3. So if I give away a 3, I am dividing it basically now because I'm undoing the multiplication. So now I just go back up to these terms and I divide both of them by 3. What's 15w divided by 3? 5w. Minus, because it's negative divided by positive, what's negative 3v divided by 3? Negative v. Done.
That's the answer?
That's the answer. And of course you should check it. And if I check it, what's 3 times 5w? 15w. What's 3 times negative v? Negative 3v. Is that the original problem? Yes. Cool stuff, hey? So, moving on to the second one. So we add a couple extra terms. 7u squared t squared plus 21ut squared minus ut. So, look for this. So what does everything have that we can give? They all do not have a 7. I think the first one has a 7. 21 is 7 and 3, so he has got a 7. But this guy over here does not have a 7. Yeah, the variables, it's every term, right? So can I give anything away except for a 1? And a 1 doesn't really matter, I guess, right? So what about the variables? What does everybody have? A u and a t. Oh, so I can give a u and a t. And if I divide every term by u and t, what's left on that first term? What's 7u squared t squared divided by ut? 7ut. Because what happens when you divide a base with the same exponent? Or same base, what do you do to their exponents? You subtract them. 2 minus 1 is 1. 21ut squared divided by ut. It's a positive, because a positive divided by positive. It's positive 21t. I agree. Some people are probably thinking, why are we using t's? I don't like t's inside my polynomials because they look a lot like plus signs. And what's a negative divided by a positive? It's a negative. And what's ut divided by ut? What's ut divided by ut? 1. You need to have that 1 or minus 1 there because it's really a negative ut divided by ut, which is negative 1. And again, how do I know if I'm right? Multiply it back through. Ut times 7ut is a 7u squared t squared, yeah? Ut times a 21u, or 21t is 21ut squared. Awesome. And negative 1 times ut is negative ut. That is our answer. We factored. We're good to go. The next part here, guys, is called factor by grouping. Factor by grouping, guys, only works if the following conditions exist. There are 4 or more terms. You have common factors that can be grouped together. So you should be able to put things together, terms, that'll have common things. And then there has to be 2 common factors that are identical to each other. Factor by grouping, guys, is going to help us a lot in 8.7, which is factoring trinomials that have a value other than 1. So 8.6, a is always going to be 1. But then when we get to the next lesson, we'll be doing factor by grouping to make it work. So what they're kind of doing here is, what if they started off with this idea of ax plus bx plus ay plus by? Notice that there's some common terms in the first 2, a common term in the second, so they grouped them up. First step, put parentheses. Second step of this process says, take a look at each set of parentheses and say, what's common? Ax, bx, I think x is common. And if you factor it out, you get a plus b left. You do the same thing with the y's, you get a plus b left. And then, here's a cool thing. you can factor again because you now have a common part to both of these terms that can be factored out, and then the outsides get pushed back together. That's why it's x plus y times the quantity a plus b. It's going to make a little bit more sense when we actually put some numbers to it versus a whole bunch of variables. So, I'll do the first one with you. The second one I want you guys to try a little bit on your own. So, first rule is, we got Rn plus 5n minus R minus 5. What I'd like you to do is put parentheses around the first two and the last two terms. And I'm going to ask you to make sure that any sign that's with this third number goes in the second group. Take the sign. The second group gets the sign. I do this because eventually you're going to factor each one of those groups. That's the next step, factor each group. You always, not always, 99% of the time, will always factor the greatest common factor of each group, which will lead us to the step where they have common things that I can then factor out. So I include the sign so you know that if I'm taking a positive value out or a negative value out, so I know what my sign will be. We'll see that in a second. Looking at Rn plus 5n, what's common? An n. What would be left over? R plus 5. Can everybody see that if I take an n off of those, I'll have an R plus 5? Now, I'm going to do the same thing with the second group. I'm going to try taking something out. And it can be 1 if I want it to be. But the goal here is to make whatever I put inside this parentheses here, we're going to put something on the outside. We're going to take something out. But the thing that goes inside here has to be the same as that one. What's here now? It's a minus R minus 5. That's definitely not an R plus 5. So what would I have to do to this group to take out to make it an R plus 5? What do I have to divide it by? Negative 1. If I divide that second group, negative R divided by negative 1 is R. Negative 5 divided by negative 1 is plus 5. So by placing this sign in the second group, I knew I was going to take a negative out, which allowed me to put negative 1 here. Do we see that we have like groups now? And at this point, I'm going to factor these out. Now, this might be different than what the book has, but I like to think, wait a minute, if I have something common, I want to take the common piece out first, which would be an R plus 5. And the cool thing is, what's the results in this are the leftovers, the things out front. N minus 1. And you're done. I will ask you to check your work, and so to check your work here means to use the 4-letter F word and fish those together. So, use FOIL, guys. First, outside, inside, last. But, without having to write it all down, R times N is Rn. That's the first one. R times negative 1, negative 1. R, which is the third term. 5 times N, 5N. And 5 times negative 1, negative 5. We have the right answer. It does work itself back out. There you go. So, I'm going to give you guys a couple seconds. Try part B. Okay, first rule says, or the first thing we need to do is put parentheses around the first two and last two, including the sign. What is common between 3NP plus 15P? What's that? 3 and p, so 3p. If I take 3p out, you get n plus 5. So the goal is to get n plus 5 again. So what should I take out of that second group? Sometimes the easiest way to think of this is I've got a negative 4n and I want it to be an n. So I needed to get rid of the negative 4, so I'll divide it by, not 4, but negative 4. So I'll take a negative 4. And negative 4 divided by negative 4 is n, or negative 4n divided by negative 4. And what's negative 20 divided by negative 4? Plus 5. And now we have a common term, and so we take that common term out. What is it going to look like? N plus 5 times the quantity. What's the leftovers? 3p minus 4. Done. Okay? Any questions, guys? Again, you should foil that check to make sure you work. There should be absolutely no spinning to the back of a book to check answers. Okay? Questions? Questions. Moving on. One last one. Try this one on your own. We'll come back. Okay. What would be the first thing we should do here? Four terms, gotta factor it. So, parentheses, first two, last two. What can I take out of that first group? Just a p. So take a p. And what's left? No p. You know, there's still some p in there. This is gonna be a great video. So what's left though, guys? 3 minus 2p. Okay. The second group, guys. The second group, I want to make it look like the first group. So obviously that group has a p in it, so therefore the second one needs it too. So I'm definitely not going to take a p out. You guys are making this hard, okay?
Back to preschool.
Okay. No, they would sit there and be fine. Okay. But that means I got to take some of those numbers. I need a 3 in the front. So maybe I should take a 6, right? Because I need 3 first. But does 6 go into 27?
No.
No.
3 does.
9 does. Okay. So if I take a 9, should I take a positive or a negative 9? A negative 9. Okay, I'll take a negative 9. What do you get? You get 2p minus 3? Are those the same?
Nope.
Wait, I could change those up. Let me change those up. That would be p of, let's change the first one. Negative 2p plus 3 minus 9, 2p minus 3. Are they the same? Almost. Why would it be a positive 9? Because I should not have taken the negative out, should I? If I leave the negative in, okay, let's just break this apart. Going back to the beginning, I should have took a positive 9 out, which would leave me with negative 2p plus 3. Would you guys agree with that? But again, those don't look the same. But a plus b is the same thing as b plus a, right? I can switch those around. We just did that above. So you should be okay with negative 2p plus 3 when I switch those around, which would match now those ones, right? So if I take those out, I get negative 2p plus 3 times what? P plus 9, and there's your answer. We're happy. The next part, guys, is solving by factoring. And to do that, guys, we will go with the zero product property. The zero product property is very intuitive. It says if you have two numbers, A and B, or just two random numbers, that are multiplied, that equal 0, what has to be true? One or both of those numbers has to be a 0. The only way to get 0 from multiplication is if you multiply by a 0. So that's what it says up here. A times B equals 0, then A equals B, or A equals Z, or wow, A equals 0, or B equals 0, or both of them do. And recall that a solution or a root of an equation is any value that makes the equation true. So what we're going to do is we are going to go down here, and I'm going to give you guys some information. To solve an equation by factoring, you bring everything to one side, and you factor it. You break it to its smallest pieces, which leads you to multiple things being multiplied. And each one of those terms or multiples can be set equal to 0 to solve it. I'm also going to tell you that you should always take your leading term or your highest degree and make it the positive one. That'll serve you later on, because it makes your life a lot easier when you have positive leading coefficients. So the first one, hey, the factoring's been done for you. 3n times the quantity n plus 2 equals 0. Guys, let's think of this. I'm going to put parentheses around that 3n. That itself is a term. It's a group. It's group A times group B equaling 0. We are going to assume we don't know which one, so we need to solve for both. We're going to set both of those equal to 0. So when does 3n equal 0? When does n plus 2 equal 0? And then you just solve them. Divide by 3, divide by 3. N is equal to? What's 0 divided by 3? 0. What's n plus 2 equals 0? I just have to subtract 2, so n equals negative 2. Done. I'm going to highly suggest that you check both of those answers, and you check them back into the original problem. What's 3 times 0? 0. What's 0 plus 2? What's 0 times 2? 0. Does 0 equal 0? Yes. Negative 2 times 3? Negative 6. But what's negative 2 plus 2? What's negative 2 plus 2 is 0. And 0 times negative 6? 0. Good to go. Next problem, you guys have to actually factor. So, it's not too bad. What's the greatest common factor between 8b squared minus 40b? 8 and b. What would be left over, guys? Divide 8b out. 8b squared divided by 8b. B. And negative 40b divided by 8b is minus 5. So what should I do with 8b and b minus 5? Set them equal to 0. Divide by 8, divide by 8, b equals 0. Add 5, b equals 5. Boom. The last problem, you have x squared equals negative 10x. This is going to go back to the idea of bring everything to one side. It really does not matter in this problem which way you go, but it generally makes this an easier problem for us if you keep the leading term or the highest degree positive. What is the highest degree? It's the 2. So it's the x squared would be the leading term. Is it positive or negative right now? It's positive. So therefore, I'm going to bring everything to that side. So to get a negative 10x to the other side, I will add 10x. So I get x squared plus 10x equals 0 now. And now I just factor it. What's common? So x, what's left over? If I divide that by x plus 10. So x equals 0. That's an obvious choice. And then x plus 10 equals 0, or x equals negative 10. And of course, you just check them. Left-hand side equals right-hand side. Anything's good to go. Your homework, guys, is the worksheet 8.5. Have a great day.